This is the amazing mt32-pi, and it tightly integrates with the MiSTer FPGA. But did you know it can also be used as a standalone MIDI synth when connected to real hardware? Let's dive in and find out what it can do right now in episode 58 of Retro Bits. Almost a year ago, we introduced the mt32-pi in the MIDI on the MiSTer episode. This combination of Raspberry Pi, software, and an optional hat allows certain MiSTer cores such as the 486, Atari ST, Amiga, and X68000 to interface with an emulated Roland MT32 or SC55. A single cable supplies power, MIDI data, and a control channel to the Pi, where an enhanced DAC outputs the synthesized music to be mixed back in with the core's audio. It's an elegant solution that really enhances games with support for these powerful external MIDI devices. But this isn't the only way the mt32-pi can be used. In the MiSTer Updates video from summer 2021, we looked at the Roland UM1 USB interface. This adapter gives us another option for connecting external MIDI devices straight to the MiSTer, such as a real MT32 or SC55. But as it turns out, you can also plug the UM1's USB end into a Raspberry Pi, leaving the DIN connectors free to attach to any MIDI-capable device or system. In this configuration, the mt32-pi can be attached to a vintage computer and act as a standalone synthesizer. So, let's do just that. For today's experiment, I've chosen to use an Amiga. Sure, the system is best known for tracker music using digital samples in the infamous Paula chip. Sure, the Atari ST might have had a MIDI interface as standard. But, as was recognized in this Amiga World article from 1989, the system was also a capable MIDI sequencer. In fact, in its heyday, nearly 30 different MIDI interfaces were sold by third parties for the Amiga. They were quite reasonably priced as well, selling for around $50. And here in the present, there are now over 300 applications for working with MIDI on the Amiga, a selection of which we'll look at shortly. Here's a recent pickup from eBay, the Pro Midi Plus. This external Amiga interface offers the standard complement of DIN connectors for MIDI in, out, and through, for connecting musical instruments, synths, sequencers, and more. The device connects to and is powered entirely by the Amiga's DB25 serial port. A serial pass-through is also provided, so you can hook up your modem or other device to the port, and the lone button on the front toggles between MIDI and RS-232 modes of operation. Before we hook this thing up, let's take a look at what's inside. The MIDI interface and protocol are themselves serial by nature, operating at 31¼ kbits per second, so we shouldn't expect much in the way of circuitry here. And as expected, it's pretty simple inside. Most of the pins on the serial connector pass straight through uninterrupted. The lines that carry data are separated out, and the push button switches between the rear DB25 pass-through and the MIDI circuitry. Here's a close-up of the PCB. The RS-232 standard uses voltage level signaling, in this case -12 to +12 volts. MIDI, on the other hand, uses an isolated current loop for signaling, with the original standard from 1983 calling for 5 milliamps from a 5-volt source. Instead of the voltage level dictating a logic low or high, the flow or absence of current in the loop does. All that this device is doing is converting between the two types of signaling with a few discrete components, transistors, and a single IC, a 6N138 optocoupler. The optocoupler allows the MIDI in signal to be relayed to the RS-232 side of the circuit without an electrical connection between the sender and receiver. There's actually an LED and a photoreceptor inside the packaging. When a MIDI signal comes in, the LED lights up. The receptor detects the light and starts conducting. This allows isolation between the low voltage and high voltage circuits. It also prevents ground loops, which can cause interference. While this schematic isn't for the Pro Midi Plus, it's pretty close and serves as a good reference. Right, let's get this thing hooked up. First, the DB25 plugs into the Amiga's serial port. Any Amiga will do. As we'll see shortly, MIDI doesn't tax the CPU much. Next, we'll connect the Roland UM1 to the MIDI in and out ports on the interface box. The cables are directional, so make sure you check their labels first. Finally, connect the UM1 to the Raspberry Pi. Make sure you use one of the regular USB ports, not the MT32-pi hat serial interface. It may look like a USB 3 port, but it's not. Now, we're ready to experience the glory that is 16-voice polyphony. No driver or configuration changes are required on the Amiga side whatsoever. MIDI-aware software will make use of the onboard serial port, and everything should just work. For the MT32-pi to function as a standalone device like this, you must enable USB support in the configuration file, but that's it. Up first is a perennial classic. Canyon.mid sounds pretty good using the no-frills MIDI play software from AmiNet, and everything just works right out of the box. Okay, one more Windows staple before we go look at some better examples. It might not be the most advanced visualization ever, but this Star Wars theme sounds great using the SC55 sound font. Where MIDI really shines compared to traditional Amiga tracker music is that it can provide up to 16 simultaneous voices of polyphony, all while barely using any CPU resources. We'll look at how that works a bit more in a moment, but for now, just give a listen to this. This visualization works fine with RTG, but the graphics are messed up in 32 color mode for some reason. Regardless, I think this rendition sounds fantastic. Oh snap! I do believe it's time for another
Nature Brain.
Every year, spring in Washington, D.C. is heralded by the arrival of the cherry blossoms. In 1912, Tokyo Mayor Yukio Ozaki gifted over 3,000 of these iconic trees to our nation as a token of friendship and goodwill. Predominantly of the Yoshino variety, these cherry blossoms, or sakura, appear in the early spring and attract more than 1.5 million visitors. The flowers are delicate and short-lived. Within a week or two, they will all have fallen. But it's their impermanence that in part makes them so special. And we're back. This is the Commodore Amiga MIDI driver, or KMD configuration screen. This shared library provides a device driver for applications to share MIDI data and interface with hardware in a device-independent manner. It allows for the creation of links that applications or hardware drivers can hook into at any time. Multiple links can be established to a single source, such that several applications can interface with one piece of hardware as well as each other. In this example, I've started playback of a MIDI file. The software connects to the KMD link, which in turn connects to the serial interface and the mt32-pi. Playing MIDI to an external device is not a CPU-intensive operation, so the system can be used normally and is able to perform other complex operations while the music plays. Because applications can hook into the KMD link at any time, I can launch the Fireworks visualizer and it will start receiving the MIDI data from the playback already in progress. It can also be used to control that playback even though it was started by another application. Pretty neat stuff. Another use for the mt32-pi is playing supported Sierra games and hearing the game music the way it was originally composed. It's my opinion that earlier Sierra VGA ports to the Amiga kinda phoned it in on the graphics conversion. Almost like they ran everything through a palette reduction tool without any tweaking and called it good enough. Later titles, such as King's Quest V here, did a much better job using the Amiga's 32 color mode. Although I still wonder if something could have been done with ham modes and sprites. It would have been interesting to see a better than VGA version. I love how the game uses the MIDI device for background noises and game sound effects as well. It really adds to the feeling of the environment. One thing I don't love is how slow these games run though. This is on an Amiga 3000 and it still moves like molasses in January. At least it looks pretty and sounds good. So, a pretty enjoyable way to play these titles on the Amiga then. But there's a catch. On both the Atari ST and the Commodore, there were only about a dozen commercial titles that supported the MT32, mostly from Sierra. It's a far cry from the hundreds of supported titles on the PC. That's kind of a shame, but let's face it, the Amiga had amazing game music without the massively expensive add-on hardware required here. Remember, a real MT32-pi was around $1,600 in today's currency back in 1987, so maybe games weren't the most compelling use case for MIDI on the Amiga. But here's one that is. This is OctaMED Sound Studio, the early freeware version. This popular sequencer has been used by quite a number of professional musicians over the years. OctaMED is capable of working with both digital samples as well as external MIDI devices. So let's have a listen to a sample track played out through the MT32-pi. OctaMED can handle up to 8 tracks, so let's add a new one to this song. Now, let's define a new instrument to use with this track. I'll just need to pick an unused channel and one of the predefined general MIDI instruments, in this case, bright acoustic piano. Now I can start entering notes. Of course, the software supports MIDI input, and I wanted to show using a proper piano keyboard. Unfortunately, I didn't have the right cable on hand to hook up my toy Yamaha at the time of filming, so I had to use the Amiga keyboard for note entry instead. Bad planning on my part, so you'll have to imagine how much easier note entry would be with a proper instrument. Anyway, this is one option for composing music for your MT32-pi or other external MIDI device with the Amiga. There are plenty of other powerful sequencer options available as well, but we don't have time to look at them today. Maybe when I get the right cable. Before we wrap up, I just wanted to show one other option, software MIDI playback. This is GMPlay, and it requires no additional hardware to play standard .mid files on the Amiga. GMPlay can handle General MIDI, Roland GS, and Yamaha XG files with up to 64 voice polyphony with 14-bit stereo output at up to 44 kHz sampling rate. As you might expect, this type of software synthesis is very CPU intensive, so an O20 or higher processor is required. By way of comparison, 4-channel tracker music allows most of the heavy lifting to be offloaded to the poly chip, so the CPU is free to handle other things such as running game code. Same when using an external MIDI synth. But software-only playback of 16, 32, or 64 simultaneous voices at CD quality sampling rates can easily tie up an entire 040 processor. Anyway, the sound quality produced by the software-only solution is quite good, as you can hear, so if you have enough horsepower, it's certainly something to try out. So there we have it, the MT32-pi as a standalone synth and MIDI on the Amiga, with or without any extra hardware. I hope you enjoyed this bit, thank you so much for watching, and we'll see you next time.